So the parabolic coordinate eta and sigma are related to the Cartesian coordinates. They are given the relation x equal to eta sigma, y equal to of sigma square minus eta square. The Lagrangian of the two-dimensional simple harmonic oscillator of mass n and angular frequency omega is. We know the Lagrangian of this simple two-dimensional harmonic oscillator T minus E. T is kinetic energy, V is the potential energy. So we know the kinetic energy is of m x dot square plus y dot square. Because it is a two-dimensional harmonic oscillator, it's depend on the two coordinate, the kinetic energy. One is x, another one is y. In our case here they are given x and y are the two coordinate of the two dimensions. So minus the potential energy of k x square minus of k y square. Our force spring constant is nothing but m omega square. So these are the thing we needed. First we can find x dot, y dot, and then square it. So x dot, already we know x equal to sigma eta. If you are taking the derivative, time derivative of this one, sigma dot eta plus sigma eta dot. Take the square of this one, x dot square should be equal to, so sigma dot square eta dot square plus sigma square eta dot square a square plus b square plus 2ab. So sigma dot eta dot sigma eta. Now come to our y dot. Y dot it should be equal to, here y equal to of sigma square eta square, it is here. So we can take of eta square is nothing but 2 eta dot. If you are taking the derivative of eta square minus derivative of eta square, sorry, derivative of the sigma square will come like this. Now derivative of the eta square will be 2 eta dot. Now we have to take the square of this one. So if you are taking square of y dot square should be equal to 1 by 4, or else we can cancel these two common factor here before taking the square. Now we can take the square. This will become eta dot eta square minus, sorry, sigma dot square minus eta dot eta square square minus 2ab. So sigma dot sigma and eta dot. Now we found the x dot square and the y dot square. Remaining thing is in x square y square. It is straightforward. So x square is nothing but eta square sigma square. Y square is equal to, here y square, y value will be the 1 by 4 sigma square minus eta square whole square. If you are taking this square, 1 by 4 sigma power 4 plus eta power 4 minus 2 sigma square eta square. Now we can substitute our Lagrangian all the values. So L equal to, first the kinetic energy of m x dot square plus y dot square. This is x dot square, y dot square. If you are adding these two, automatically the last plus 2 sigma dot eta sigma minus 2 sigma dot sigma eta dot, this will get cancel each other. The remaining term will come, sorry, here if you are taking square, this should be plus. Don't forget y dot. If you are taking a square plus b square minus 2ab. So finally you will get eta dot square sigma dot square plus sigma square eta dot square in this term plus sigma dot square sigma square eta dot square. So the kinetic energy has done. Now come to the potential energies of k x square plus y square. We can write in the next step of m. Take the common terms. So here eta dot square, yes, sorry, sigma dot square. You can take the one sigma dot square common inside eta square sigma square plus same if you are doing eta dot square, if you are taking common out inside sigma square eta square, close this. Now come to our potential energy of k. I am substituting m omega square, open the big bracket, x square plus y square. Here x square is nothing but eta square sigma square plus y square is nothing but plus 1 by 4 sigma power 4 eta power 4 minus 2 sigma square eta square. So now what we have to do of m, take the common factors are out. So here it will come eta square plus sigma square. So eta sigma dot square eta dot square. Now if you are multiplying with this, it will come like minus 1 by 2. So if you are adding with this one, so 1 by 2 m omega square, the first term eta square sigma square minus 1 by 2 eta square sigma square, it will become plus 1 by 2 sigma square eta square. So here this will become 1 by 4 sigma power 4 plus 1 by 4 eta power 4. So the final option is you can write like eta square plus sigma square eta dot square plus sigma dot square minus of m omega square. This we can write as, or else 1 by 2 you can take common out. If you are taking 1 by 2 common out, or else 1 by 4, if you are taking 1 by 4 common out, then remaining terms you can write like sigma square eta square whole square. So take the, here I am missing m, take in the both the two terms of m outside as well as one of the eta square sigma square out. So now inside eta dot square sigma dot square, the first term, the second term minus 1 by 4 omega square sigma square eta square. So this is the answer.